thing we're going to look at is just a couple of these scatter plots and identify the type of function that this trend is. What type of function does this? What parent graph kind of looks like that? Oh, could be. A radical, yeah, this could be a radical. Square root of x, or like if it continued, like a radical has an endpoint, like if this were to continue, which we can't really tell, it would be a log. Okay? And you can run both and write an equation for it that's radical or log, so we'll look at that. This one, hopefully easy, linear. This one, exponential, assuming, again, and you're making an assumption that this is going to be flat the rest of the way, right? It could, though, be quadratic, couldn't it? Okay? Usually quadratics aren't used as often as exponentials, but it's a possibility. And the last one, linear. Okay? So the first time through this, just follow along. You don't have to do it on your calculator, just watch. So we're given data. The populations have been recorded for years. Okay? Write an equation for the best fit correlation of the data given above. Years since 2000. So these are my x-coordinates, but what would my x-coordinate actually be? 2 years since 2004, 5, 7, and 9, and my population is as stated. So again, don't do this, just follow along. So you'd go to your stats and you'd edit your list to insert the information. Your x coordinates go in the first column, your y coordinates go in the second column, so you just enter those in. Now, we want to first, because it doesn't tell us, sometimes it will tell you, do an exponential regression, do a quadratic regression, do a linear, it will tell you. But when it doesn't tell you, you want to look at your scatter plot first. So you, and we will do this in a second, you have to first turn your scatter plot on. So if you go to this blue stat plot, second y equals, and we'll do it again in a minute, it's got all your plots are off right now. So I would click on one of those, and I have to first turn it on. And this does line graphs, histograms, box and whisker plots. We like that it's highlighted on the scatter plot right now. Again, just wait. I'll talk you through this in a minute so you all can do it. Your x list is, your x coordinates are coming from list 1, your y list from list 2. Okay, so we've got our scatter plot on. When you hit y equals, you want to make sure that anything that was there is gone, because you don't want it graphing functions on top of your scatter plot. And then most importantly, you want to set your window so that it's going to hit your points. So our x numbers were between 2 and 9. So I can go from 0 to 10, and that'll hit all my x coordinates. My population is anywhere from 5,000 to above 7,000. So on my y-axis, I want to look at this from 5,000, let's say, to 8,000 and make sure I can see something. Because if your window's not right and you're only looking negative 10 to 10, you're not going to see a thing because your y-coordinates won't even be on the graph. So now when I hit graph, I should see a plot. Yes? Now what does that look like to you? Looks linear, okay? Again, depending on the curvature, you're going to have to decide sometimes, and sometimes they will tell us. So if we're deciding here, it does look linear. Population growth generally happens how, though? Exponentially. So maybe I'll run both just to see. So here's your calculator. So stat, calculate. Now, before I actually run anything, I'm going to show you all your options. These are regressions. You have a linear regression if you think it's a line. Quadratic regression if you think it's a quadratic. Cubic regression, which we will never do because we haven't done cubic functions. Quartic regressions we won't do because we haven't done quartic. Another version of linear, the only difference between 4 and 8 is that this is ax plus b. So So your A value is the slope and the B is your y-intercept. This one being A plus BX, B is your slope, the A value is your y-intercept. There's really no difference between those two. ln, that's what they'll do for a log regression. Ln is the natural log. So if you think something's a log, it's an ln regression. Exponential regression. Power regression we won't do. And trig. They'll do, if something has like a seemingly trig pattern, they'll do a sine regression. Not a cosine, but a sine. Because all cosines can feasibly be considered sines. That's it. So we think, we'll start with the linear one here. And then again, it's going to ask you, where is your x-coordinates coming from? Not list 2, they were actually list 1, so I'd have to change that. Then there's list 2 for the y, there's no frequency, so we'll just calculate. So what they'll give you is the general format. So under here I'm going to write linear. And they'll give us y equals ax plus b. They're telling me that the a is 260.7 as well. I'll just round to the nearest whole number to keep it fair, to keep it clean. 261x plus my b value of 5,036. And if I were to run an exponential, I would just do stat, calculate, go down to exponential regression, and again, it's going to give me at the top the general format, a times b to the x power. So our a is 5,158. Our b, I'm going to do 1.04 to round that to the nearest like percentage growth to the x power. So in a linear, this is my y-intercept, this is my slope, yes? So they would say in the year 2000, because that's my y-intercept, year since 2000, there is a population of 5,036, and it's growing by 261 people per year. Okay? Where's our y-intercept here? Which of these numbers is your y-intercept? When x is 0. The a is always your y. It's been a while since we've been in the exponential chapter, which is why this is kind of review. That's your y-intercept. So this one is saying in the year 2000 that your population was 5,158, and it's not increasing by a certain number of people per year. That's a linear trend. It's increasing by 4% each year, which is an exponential trend. Okay? And generally speaking, you could argue that either is happening. Any questions on that? Does anybody remember? Hold on. Oh gosh. Do you remember what R is? Anybody remember learning about an R? Yeah, go ahead. Yeah. Well, I'm going to kind of give us, I think I'm trying to give you a feel here. Honestly, it would be more obvious than that. I just kind of wanted to show you that anything can be done in any way, but what's more accurate is they would never be that close. It would either be obviously exponential where it'd have this curvature, or it wouldn't. And on that, it would be more obvious than the one we just looked at. Okay? Let me just recalculate this and see if I got what I was looking for. Yes. Do we remember this from Algebra 1? What does R tell you? It tells you it's called your correlation coefficient. It tells you the strength of this correlation, how perfectly modeled it is. And the closer this is to 1, the more perfect it is. Okay? Or -1. Okay? If it's 0, then it's a completely off scatter plot, and you probably ran the wrong regression. But this one has a correlation coefficient of 0.998. So that's pretty strong. 998152357 to be exact, just in case they're both really good. So the correlation coefficient there is very close to 1. If I rerun that exponential one, the strength of that correlation is 0.9985. Which one, now looking at it, is better? Exponential. Okay? It was hard to see that from the picture, but the closer it is to 1, this is actually the better option. Okie doke? Alright. Next one, and this one let's all do together. So the first thing I want you all to do is go to your y equals, make sure everything is cleared out. Then hit second y equals and turn on your first plot. So you hit enter in there, turn it on. If you don't have a calculator, come get one, please. And then go to your data list, edit, and start inserting stuff. If you have a question at any point in time, ask it, because I don't want you to get behind, and then we'll be 12 steps ahead of you and you've been doing nothing. Andrew? Stat. Same place and then edit. Same place we typed in stuff for when we were running our one variable statistics to get the mean, median, mode, all that stuff. So edit. So this next one, temperature, every 2 minutes. So in my X column, I'm plugging all those times. And the temperature in Celsius. Once we have those all in there, we have to think about what window is going to be conducive to our x coordinates and what window is going to be conducive to our y coordinates. So hit your window button, and what are you going to put for your x window, Cameron? 0 to what? 20. Do you like that? Yeah, you went from 0 minutes to 20 minutes. How about your y window, Madeline? Or Kaylee? Between you, and Grace, the three of you. Okay, what'd you say? 35 to 41. I like it. Cameron, question? Oh, good catch. You see the 14 data point? He's saying that's already lower than 35. These aren't in order. Okay? So let's go 33 to 41 is good. Is anything above? Oh, yeah, there's also stuff above 41 to that point. Let's go to 43. Good, Mason. Okay, so now hit graph, and you're looking at something. What does that look like to you? What'd you say? Sine. Very good. So go to stat. Maddie? Maggie, what is going on with me today? Just called you Maddie. Okay. Okay, go to your window. If you have a window range error, tell me what your X-min is. What was your X-min? What was your X-max? Okay, what was your Y-min? Tell everybody. Okay. So that's, you go back to, if it tells you got a window range, go back to your window and see what you could have done wrong. Okay, so now go to stat. Are we all good? Lydia? Okay. Bring me your thing. Hers isn't showing anything. So she's got her lists in. They're all there. She's got her window in. Good. Did you turn your stat plot on? Second y equals. She doesn't have anything on. Of course it's not going to show you a scatter plot if you didn't tell it to turn it on, okay? Now we should be good. Anybody else? These are all things that are worth bringing up because you might be on the regions and this happens and you're like, what do I do? So all these troubleshooting things are things to look at. So we're good. So now we're going to calc, and we said it looked like a sine graph. Sine regression. List 1 should be your X list. Double check that this is right, because if you left off on a weird problem, it might not be. Oh boy. And then run that regression. Okie doke. And oops, stat. I just blew it. Sine regression. Sorry, I'm trying to do two things at once here to get ahead of you. Sine regression, calculate. So again, at the top of this screen, it's going to give us the general format. A sine, parentheses, bx plus c. It's a little bit different than our general format, but you want to take what they have. So I'll round everything to the nearest tenth. So I will write y equals 3.9 is my A, sine, parentheses, b is 0.4, x, plus a negative 0.7 is going to be minus 0.7, close parentheses, plus the d value of 38.5. Great. Good? All of our numbers should be exactly the same. If they're not, it's because somebody typed in a data point wrong. So make sure you type in these accurately. So just out of curiosity, because it's worth reviewing, what's the midline of this? Maggie? 38.5. What's the maximum value that this best fit line gets to? Best fit curve. Because if our midline is 38.5, what's our amplitude? 3.9. So, Nate? So you just added 3.9 up, right? So 42.4, that's fairly accurate for the actual data, right? And the minimum would be 3.9 below 38.5. Good. Okay. All right. The next one, don't do it. I've already entered the data so that we could kind of hurry this along. So I've entered the data, window values. Oh, let me go back to that. Oh, it didn't give me a correlation coefficient on that one. Sine curves must not have that. 0 to 15 for age. And my lowest weight, 7, to my highest weight, 26. Did I turn my stat plot on? I'm on a new calculator now. Enter, graph. There it is. It's hard to see, isn't it? What is going to happen to do babies grow faster early on or later in life? How about humans? Does their weight change on a grand scheme from ages 0 to 90? Does it grow faster when they're young or when they're old? Young. So what is going to happen, and just take this for what it is so we do this type of regression because I want to show you something. This will eventually even out. Maybe not till they're 20 years old, but it will eventually even out. And so that graph is what kind of shape? Kind of like this one, right? Did you notice that there was no radical regression? Okay, so we have to run a log regression. Now, watch what's going to happen if I go to Stat, Calculate, and run a log regression. List 1, list 2, calculate. An error because of the domain. What kind of numbers are you only allowed to take logs of? What'd you say? Nope. Positive. You can only take logs of positives, and the issue here is that in my list, if I look at my list, because it's 0 months, that's throwing things off. So you might need to adjust everything by just making it make everything like 0.1 and 3.1 and 6.1 would be one way of potentially adjusting it. Or leave off that data point maybe. I wouldn't do that on the test, but you just have to think about that. If you get an error on a log, it's because it has a limited domain. Nothing else has a limited domain, right? Linears, exponentials, quadratics, all of that. Radicals would as well. We wouldn't be able to take the square root of a negative. But something to think about if that ever happens. This is another, it tells us in this case that it's a sign regression. It asks some follow-up questions based on our linear regression, but I'm going to ask those, and I kind of already did about this previous one. What is our period here? Remind me. What is the period formula? 2 pi over b. What's my b value here? 0.4. So period equals 2 pi over 0.4. So if I do that on my calculator, 2 pi divided by 0.4, this chemical reaction, whatever it is that we're looking at, follows through a cycle that repeats every 15.7 minutes. Do you follow that? Okay, so we can be asked follow-up questions with these as well. How about the phase shift? That's the only thing. Why am I not ready to say what the phase shift is? You remember my format looks like this? The one I've had you guys use all year? Looks like that with the B already factored out. That's your phase shift. We don't know what our phase shift is yet because we would have to factor out that 0.4. Leaving, and what's negative 0.7 when I divide out a 0.4 is negative 1.75. Now I have my phase shift. It's shifted 1.75 units to the right. Do you follow? Okay? Alright, so kind of a little bit of review of functions and meanings, but in the grander scheme of things,